Today we're still in the world of graphing, but we are going to focus a little bit more on the parent function. So what we need to know is that the parent function is y equals, and it's just the letter x. There is no actual number in front or in the back when we write this in parent function. We said earlier that another way to say y equals is to say the phrase f of x equals. So the parent function is y equals x, or f of x, which is just y, equals x. So in my parent function, there is one x in the problem, so I put a 1 there. And there is no number in the back, so I put a plus 0 in the back. So the slope of my parent function is 1. My y-intercept, the b, is 0. It says, why is the slope 1? The reason why the slope is 1 is because there is one x in the question. Why is the y-intercept 0? The reason is because there is no number in the back. So now that we have a slope and a y-intercept, we can graph our parent function. So I'm going to begin at 0, b stands for begin, and I'm going to move with my slope up 1 over 1. So notice, it will always go through the origin. It's always a positive line, and it's always going up 1 block and over 1 block. So that is the parent function, y equals x, which is the same as y equals 1x plus 0. So in this one it says, where is the parent function? To be silly, I said find the mother function. So the parent function, the original function, the function that goes through the origin, would be this one right here. So that's the letter B. Go ahead and try the same thing with this question, and this question. Remember, the parent function goes through the origin in a straight upward direction, through the origin. Okay, so now we're going to take our parent function and we're going to shift it. We're going to move the graph up or down. So in my first example, y equals 1x plus 0, we said was our parent function. So my slope is 1 and my b is 0. We're going to graph that first. I begin at 0, and then I move up 1 over 1. Okay, that's the line y equals 0. The next one, it's y equals x plus 0. This next one is y equals x plus 4. So again, my slope is 1 because there's one x there. Okay, so if my new y-intercept is 4, I'm going to put a dot on 4. And just like before, my slope is 1, so I go up 1 over 1. Okay, so I took my original line and it shifted up 4 units. It says plus 4 in the back, so that means it went up 4. So that's what we'll put on our line. Describe the transformation. It moved from my original parent function to my new line. It went up 4 units. Okay, let's try the same thing with the next one. It says have your parent function, okay? Slope is 1, y-intercept is 0. I can graph that. Up 1 over 1. Okay, next equation. Slope is still 1. We're not messing with the slope. We are only shifting the back number. We're only shifting the y-intercept. So my y-intercept of the new graph is now -3, but my slope doesn't change for these. We are just shifting it So there's my new line. So from my parent function, my new line dropped down 3 units. You could know that because it was at 0, and now it's at -3. So it dropped down 3 units. Pretty easy. Go ahead and try these two. Graph your parent function. Begin at 0, go up 1 over 1 is your slope. And then your new one, slope is 1, y-intercept is 7. Is that a 1 or is it a 7? Actually, I think it's a 1. Yeah, we'll call this a 1. So number 3, this is a 1. It's just fancy. Okay, so graph it and see where it moved. Okay, so now we are going to do the exact same thing, but this time instead of saying y equals, it says f of x equals. But just like before, the back number always shifts the graph up or down. You just did that. If we change a number in the back, it is always, always, always going to shift my graph up or down. So in my original graph, my parent function, f of x, just means y equals. So y equals x means there's a slope of 1 and a y-intercept of 0, just like before. Okay, that's my original parent function. Now it says, take that parent function and shift it up 3. Change your back number to a 3. So that means my slope is still 1. I didn't touch the slope. But my new back number is a positive 3. So that's my y-intercept, and now I'm going to shift up 1 over 1. So my graph was at 0, 0, and now it's at positive 3, so it went up 3. Not too difficult. Graph your parent function, shift the back number is your y-intercept. Okay, same thing. F of x just means y equals. So y equals x is the function 1x plus 0. My slope is 1. My y-intercept is 0. We begin at 0. And we move up 1 over 1. Okay, new one. It says take f of x, take your original function, but now make your y-intercept a -4. Slope didn't change. Back number is now -4. So I begin at -4. And my slope is 1. So I go up 1 and over 1. That's not a good graph. Okay. So this graph dropped down 4. This one went down 4. Okay, go ahead and try numbers 3 and 4. Graph your parent function. Your parent function always has a slope of 1 and a b that is 0. Then shift your back number is your y-intercept number. Change it to a 2. Begin at 2, but the slope does not change. So when a back number is a plus or a minus, it only changes your y-intercept. Okay? So now that we're comfortable with shifting the y-intercept, the b, the back number, we are now going to shift the slope. Okay? So what this means is if I have a parent function like we do, there we go. Okay, so this is a parent function. If it becomes steeper, it's going to look like this. The y-intercept did not change. The y-intercept is still 0, 0. But instead of my line being like this, which was my parent function, this line became steeper. This became steeper. That's called a stretch. You can put stretch or steeper. It's the same thing. So in this one, here's my parent function. When it becomes flatter, it would look like this. Flatter. It became more flat. The y-intercept didn't change, but instead of going up 1 over 1, we're now going up 1 and over 4. So to vertically stretch or compress is to stretch or compress a line. Okay, so let's try a couple of these. Again, we always start with our parent function in this piece. In our parent function, there's no number in the back, so that's a 0. My slope is 1, so that's 1 over 1. Okay, so here's my line, y equals x. In my new equation, my slope is now a 2. My m is 2. There's still no number in the back, so the b is still 0. So in this one, I'm going up 2 and over 1, up 2 over 1, up 2 over 1, up 2 over 1. So in this graph, the y-intercept didn't change, but it became steeper. Another word for steeper is that it's stretched. It's called a vertical stretch. It became taller or steeper. So if my slope gets bigger, then my line gets steeper. If this was a hill, this would be a really steep hill. Let's try another one. Again, parent function. 1 is this, 0 is this. Begin at 0. You should get very comfortable with graphing the parent function after today. Okay, there's the parent function. That's my original graph with no changes in the front or the back. My new graph, though, has a 1/2 as its slope, 1 over 2. There is still no number in the back, so we still begin at 0. So here's 0. In this slope, I'm going to go up 1 and to the right 2. So this graph was standing tall, it was standing steep. Now it got flatter. So this is called less, we'll call it flatter, it's fine. This line became flatter. Another word for flatter is compressed. My line compressed. It got smaller, it got flatter. It like smushed towards the ground, it compressed. We'll do one more together. So in number 3, again, parent function. Y is 1. Y-intercept is 0. I'm actually going to move this so we have more room to write. Okay. In this one, my slope is a -3. There's still no number in the back. We graph this by going down 3 and over 1. Okay? So this graph is now a negative slope. So this graph described the transformation. We can say that it became negative. It's going down the hill now. It's a negative slope. And it did become steeper. This is a steeper graph than the previous one was. The y-intercept is now a 3. The slope is now a 3 instead of a 1. So that made it steeper. So my graph is now negative, and it's a steeper line. So you can say steeper, and then the other would be flatter if it became flatter. So go ahead and try number 4. Graph your parent function, and then graph your new one. You're changing the slope. When you change the slope, it gets steeper or flatter. Okay? So now, just like we did earlier today, f of x is a fancy way of saying y equals. So it's still just the parent function. They're just trying to make it fancier than it needs to be. So y equals 1x plus 2. Here's a 1. I'm sorry, 1x plus 0. Sorry, guys. So I begin at the number 0. We go up 1 and over 1. Again, we graph the parent function first. So that way we can see what the original graph looked like. So now, if there's a number in front, the number in front is the slope. So this new slope is 5. There still is 0 in the back, so I'm still going to put a 0 in the back. So I start at 0, 0, but this time I'm going up 5 and over 1. Down 5 and over 1. This graph became much steeper. It is a vertical stretch. This graph stretched. It became steeper. Vertical stretch. The number in front is the slope. The slope makes it steeper or flatter. This one became steeper. Okay, let's do another one. Again, parent function is just y equals 1x plus 0. My slope is a 1. My y-intercept is a 0. I'm going to go up 1 and over 1. Okay. My next one, there's a number in the front, so that changes the slope of my line. There is still no number in the back, so my y-intercept is still a 0. But in this one, it's negative, so I drop down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, so this graph is now a negative line because it's dropping downwards. And it did get a little bit steeper. It's a 2 now. It used to be a 1. The bigger this number is, the more steep it is. So this graph became a little bit steeper. Another word for steeper is that it stretched. It was a vertical stretch. Okay? So go ahead and try the next few on this page. So try numbers 3 and number 4. A number in front changes the M. A number in the back changes the B. Once you do 3 and 4, you're going to try the practice. Parameter just means we're changing the line. So you're either changing the slope or you're changing the y-intercept. If the number is in the back as a plus or minus, that means that we're changing the y-intercept, which is the B. Okay? So in the first example, the number's in the back. That means you're changing the y-intercept. In number 3, the number is in the back, so you're changing the y-intercept. If the number is in the front, that means we're changing the slope, which is the M. Okay, so in all of these, you are either changing the y-intercept or you're graphing by changing the slope. Go ahead and try through these, and that is everything for today. So you should be a little bit more comfortable with the parent function, y equals 1x plus 0. Then we can take that parent function and shift either the slope, the number in the front, or the y-intercept, the number in the back.